Hello everybody, and welcome back to A1 Math. So today we're going to be talking about the volume of prisms. But before we get into that, let's talk a bit about what we know already. We know how to calculate the area of various two-dimensional shapes, right? Square, rectangle, triangle, and a circle. We also know how to calculate the surface area of various three-dimensional shapes, rectangular prisms, triangular prisms, and cylinders, right? So our surface area is simply the sum of all the two-dimensional shapes within the prism. Right? Nothing new there. What we will learn today is we're going to learn how to calculate the volume of various three-dimensional prisms. We're going to look at rectangular prisms, we're going to look at triangular prisms, and finally we're going to look at cylinders. So the volume of a prism can be calculated using the following formula. We have the cross-section area multiplied by the depth of the prism. Now, what does this mean? What is cross-section area and what is depth? Well, cross-section area is simply the area of the base. So it could be a square, could be a rectangle, a triangle, or a circle. And now we know how to calculate the area of our two-dimensional shapes, right? So the area of a square, two-dimensional square, is simply the side squared, right? Side times side. The area of a rectangle, we know to be length times width. The area of a triangle, we know it to be 1/2 base times height. And the area of a circle, we know it to be pi r squared, r being the radius of the circle, right? Nothing new there. And the depth is simply how much volume or how high the cylinder or the rectangular prism or triangular prism, how high the prism itself is. So let's get into a few examples here. We're going to start off with rectangular prisms. So we have our formula, the cross-sectional area multiplied by the depth of the prism. This is the formula for any prism, whether it be rectangular, triangular, or a cylinder. So let's start off by doing and solving for our cross-sectional area. So like I said, that is the two-dimensional shape on the base of the prism. In this case, it is a rectangle. So our cross-section area is simply our length multiplied by our width. In this case, it is 7 meters multiplied by 4 meters, giving us a cross-sectional area of 28 meters. Perfect. Now, what is our depth of our prism? The depth of the prism. Well, that is simply the height. In this case, 3 meters. So therefore, our volume is simply our 28 meters multiplied by 3 meters. Sorry, our cross-sectional area is actually meters squared, right? Because area is meters squared. We don't want to forget that. Doing out the multiplication, we get a volume of 84 meters cubed. So with area, our units are always squared, right? With volume, our units are always cubed because now we're looking in 3 dimensions. Let's try another one. Here we have a square. So again, we're going to first find our area of our base, which in this case, we know it to be side squared. So we have 4.1 meters all squared. Perfect. Giving us an answer of 16.8 meters squared. We have our cross-sectional area. And now we multiply that by our depth, which is 4.1 as well, because it's a square. So our volume is equal to 16.8 meters squared multiplied by 4.1 meters, giving us a volume of 68.9 meters cubed. Now, you might have noticed something peculiar with cubes. Since all sides are equal, can we not just say the volume of a cube is equal to its side cubed? Its side cubed. And this makes sense because the area of a square, a two-dimensional square, is the side length squared. The volume is the side cubed. And you could try it. So you could plug 4.1 back in to our side. And we're going to cube that. And we will get an answer of 68.9 meters cubed. Let's try triangular prisms. Again, our formula for volume does not change. Our cross-sectional area, CSA, I'll put, is simply our area of our base. In this case, our base is a triangle, and we know our area for triangle to be 1/2 base times height. So we have 1/2 base of 10 multiplied by 13, giving us a cross-sectional area of 65 centimeters squared. Perfect. Now we simply multiply it by our depth of our prism, giving us a volume of 65 centimeters squared multiplied by the depth, which is 15 centimeters, giving us a final answer of 975 centimeters cubed. So nothing changes with triangular prisms versus rectangular prisms. The only thing changing is our formula for our cross-sectional area. Let's try another one. So at first, we're going to solve for a cross-sectional area, which is 1/2 base times height, because again, our base of our prism is a triangle. So in this case, we have 1/2, 26 meters, multiplied by 9 meters, giving us a cross-sectional area of 117 meters, 117 meters squared. And now for volume, we know that we take our cross-sectional area and we simply multiply it by the depth of the prism, which in this case is 12 meters. So we have 117 meters squared multiplied by 12 meters, giving us a final volume of 1,404 meters cubed. So again, nothing changes between triangular prisms and rectangular prisms. The only thing that changes is our formula for cross-sectional area. Now with cylinders, it is the exact same formula. We have cross-sectional area multiplied by the depth of our prism. Now for cross-sectional area, we're looking for the area of a two-dimensional circle. So we know that to be pi r squared, r being the radius of the circle. So in this case, we have pi multiplied by 7 squared. So if we remember our order of operations, we always do the square rooting first before the multiplication. Sorry, the square first before the multiplication. So in this case, we have 7 squared, and then we multiply it by pi, giving us an area of 153.9 meters squared. So this is our area of our base circle. And now we simply multiply it by our depth of our prism, in this case, 12 meters. So our volume is equal to 153.9 meters squared multiplied by 12 meters, giving us a final volume of 1,847.25 meters cubed. Now this one's a bit different. Our formula remains the same. So it's a cross-sectional area multiplied by a depth of our prism. In this case, for cross-sectional area, again, for a circle, a two-dimensional circle, it is pi r squared, right? That doesn't change. However, we're not given a radius, we're actually given a diameter. But if we remember our identities of circles, we know that diameter is simply 2 times the radius. That means to solve for radius, we simply take our diameter and divide it by 2. So in this case, we have an extra step because we're given our diameter, but that's no problem. We know how to convert that to radius. So going forward, cross-sectional area is equal to pi 3 squared, right? So I got the 3 by simply dividing 6, which is our diameter, by 2, giving us a cross-sectional area of 28.3 centimeters squared. Perfect. And now for volume, we simply take our 28.3 centimeters squared, and we're going to multiply that by the depth of our cylinder, in this case, 14 centimeters. So multiply by 14 centimeters, giving us a final answer of 395.8 centimeters cubed. So a good thing to remember is our formula never changes for volume of prisms, right? It's always our cross-sectional area multiplied by the depth of the prism. The only thing that changes is the cross-sectional area formula, because our prisms change from rectangles to triangles and even to circles in cylinders. Now let's do a word problem. Everybody's favorite is word problems. So the side of a cube is 4 centimeters. The base of another rectangular prism is 2 centimeters by 10 centimeters. If these two solids have the same volume, what is the depth of the rectangular prism? So it's always good when you're looking at word problems to break it up and draw pictures as well. That's always a good start. So the side of a cube is 4 centimeters. So the side of a cube is 4 centimeters. The base of another rectangular prism is 2 centimeters. The base of another rectangular prism is 2 centimeters. By 10 centimeters. So we'll go 10 centimeters along the back, 2 centimeters by 10 centimeters. If these two solids have the same volume, what is the depth of the rectangular prism? So we're looking for this length here. Well, let's first find out what the volume is of these prisms. So we can't calculate the volume of a rectangular prism because we don't have the depth of the prism. However, we could calculate the volume of our cube, right? Because the volume of a cube is simply our side raised to the exponent 3. We discussed that earlier. We went through how that makes sense. So the volume is simply 4 centimeters cubed, giving us 64 centimeters cubed. And it says the volume of each solid is equal. So that means the volume of this cube of 64 centimeters also is the volume of this rectangular prism. So the volume over here is also 64 centimeters cubed. Okay? Now you should see how we're going to solve for depth. So remember our formula for volume is our cross-sectional area multiplied by the depth. To solve for depth, it's simply our volume divided by our cross-sectional area. We can calculate the cross-sectional area because we're given the length and the width of our rectangle on the bottom. So our cross-sectional area is simply length times width, or 2 times 10, giving us an answer of 20 centimeters squared. And now, if we divide our volume of 64 divided by our cross-sectional area of 20, we will get our answer of the depth of the prism. And that's not squared or that's not cubed because that is simply the depth of our prism. Great. So now we not only know how to calculate surface area, we know how to calculate volume. All of this is done by three-dimensional shapes.